Factoring using substitution. I believe we should be in 2.5, but whatever. So factoring using substitution, this is the final way of factoring that we're going through. Basic idea is to replace something that doesn't look very nice with something that does, or with a single variable. So we're replacing binomials mostly, but you could replace trig functions or letters or, groups of words, whatever. Just replace it and make it look nicer. Then you're just going to factor whatever you got completely, replace what you changed back into the problem, and then factor again if you can. So here's an example. You got x plus 3 minus 4, this. Now it's the x plus 3's that are the problem. Now normally we would factor out an x plus 3, but this 45 doesn't have one, so we can't do that. So what we do is we say, okay, well, we're going to let a equal x plus 3. All right, so if we do that, you can pick any letter you want. Some people call it U substitution, so they use a U, but it doesn't matter, whatever you want to use. Pick a letter, your fave. Okay, so I have this. I can factor this. This is straightforward guess and check. These two multiply to a positive 45, and when you add them, you get 14. Then we replace. So that was the factor. I factored that completely. Now I have to replace it, put that back in where it belongs. So I'm going to put x plus 3 minus 5. I like to put parentheses. If you're good with signed numbers, it may not be necessary, but you never know. Okay, so I want to combine like terms if I can. I can combine those like terms. So 3 and negative 5 are good. Those are like terms. 3 and negative 9. And that's it. So this guy factored is actually this. Crazy. Interesting. All right. So we have a problem like this. Again, it's a minus b that I don't like looking at. So if I don't like it, I'm going to call it x this time because I like x. All right, so this becomes 5x squared minus 3x minus 2. And I factor. Straightforward guess and check. These two multiplied to those two. And then I got to make it negative 2 here. But it's got to add to a negative 3. So that's definitely not it. This has to be a 1, and this is a 2. You can check. So this should be negative, and this should be a positive. I'm going to erase this, but 5x. So if I make this negative 5x, just as a check for you guys to believe me, when you add these together, you get negative 3x. So that's what I need. Good. The downfall of using x is you think that the problem is done now, and it is not. I have to replace that a minus b back in. So I'm going to do that. Okay, and do whatever math or factor if you can. So here I can distribute those 5s through. I'm keeping the outer parentheses because they're still needed. It's still multiplication here. Okay, but that 5 does not multiply to that 2. And then a minus b, there's really nothing happening there. There's no like terms. There's no multiplying. So that's it. Factored. All right, so sometimes it looks nasty, and sometimes it doesn't. So here, this looks super bad to start. But if I replace x squared plus 6x with a letter, again, I just don't like using the same letter in the problem. So I'm going to replace it with x squared, a with x squared plus 6x. So this becomes a squared plus 17a plus 72. You can almost like sigh in relief here because this is so much easier than looking at that other mess. So factor that. Okay, if you need help remember how to factor that, go back to the trinomials videos. Okay, and now I have to replace the a here. So that is a key component, remembering to replace that. A doesn't have, I'm not multiplying anything times a, so this is a. I just don't have really enough room here to put parentheses and then get rid of them. Okay, and now finally, these two are trinomials, so you have to give it that old college try. You have to try to factor those, and because I made up this problem, this does work. So I factored this one right here, x plus 4, x plus 2. Okay, and factor this one here, x plus 3, x plus 3. So it's actually x plus 4, x plus 2, and then x plus 3 squared if you want to get fancy. All right, have a good day.